biggest consideration there, groups are sizes of 3. 3 people. The tables generally should have 9 chairs at them. Some have 10, which is a little awkward. It makes my life a little bit more difficult. But for the most part, all the tables have 9 chairs. So groups of 3 is what we're looking for. 3 is a nice number for groups. It's kind of ideal because if you have 2 people and one person's not there, it's not a group anymore. It's just an individual person. If you have a group of 4 people, you end up running into the problem where I kind of assign, the amount of work I have is reasonable for 3 people. If you have 4 people, it's very likely someone's just going to be sitting around twiddling their thumbs, not doing something. So 3 people is kind of the golden number. If someone's not there, you still got 2 people, you can still get it done. And that's the logic there. Anything beyond 3 gets inefficient. Let's say someone or some ones will be sitting around not doing anything, which is not ideal, especially if we're getting credit for all this stuff. So keep that in mind. So make certain you're here on Thursday. There is the football game this Thursday. That cancels classes after 2 p.m. Our class is before 2 p.m., so we're still going to meet, which might sound like a bummer. The reality is, if the football, so my lecture class is they start at 3 p.m. The reality is I still have to cover the same amount of stuff. Just because the football game kind of happened, UCF requires I cover a certain amount of content. Them canceling that day, I don't get a magical extra day. So the reality for them is I'm just going to record the class, and then they're going to have to kind of watch it in their free time and figure it out, which is not ideal. Certainly not ideal. Hopefully you all have already seen some of the benefits of like in-class problem solving, and that it just is, if you have questions, I can actually answer them during class. It's a wild concept in large lecture classes at UCF where you have 200 people. If you have a question, you generally wait till the end or just figure it out yourself. So hopefully you all have found some benefits already. If not, hopefully you will as time goes on. We do clicker questions also. Yeah, I already mentioned that. So that's already there. I did make it because there were some questions about attendance. If you have a physical iClicker, there was a setting I found that I just need to click. So moving forward, it should automatically mark you as present if you use a physical iClicker. So hopefully that resolves that concern. And then outside of that, I hope that you all have started your problem sets. That first kind of week of problem sets. Reminder to you all, my recommendation, so your quiz is due this Saturday. The quiz is open. It's due this Saturday at midnight. You get 2 attempts. You want to have started your first attempt ideally by this Wednesday, by tomorrow. The rationale being, you take the attempt. If you do awesome, great. Life is good for you, easy peasy, no harm. If you don't do well in the first attempt, you have time. You have time to ask me questions or ask other people questions or just generally kind of figure it out. If you wait till Friday or Saturday to do the first attempt, I will not respond to your emails if you send me emails after 5 p.m. on Friday. So I'm not going to be able to help you. That might still work out for you and all that kind of stuff. You do what works best for you. That's just generally, the supports available to you are much less on the weekend. To that end, there was an extra support that popped up. I sent an announcement about it. So you all have our learning assistant and our graduate teaching assistant. They're in class, and at some point the learning assistant will have the help room hours. Once I figure that out, we'll post that. Basically like office hours. But for Leo here, it'll be immensely useful. It'll be in PSP. We'll get to that when we get to that. But there's also SARC tutoring, which is a fantastic, it's basically the same thing. It's an undergraduate who took the class, did awesome. And I posted, he sent me an email. The individual's name is David. I think last name Fernandez. So I posted an announcement with the details about his, when he will be available. Again, it's just an extra resource. At the end of the day, you all have lots of resources at your disposal to be successful in this class. A general rule of thumb with a lot of college classes is you put the time and energy in, it'll go okay for you. For the most part, there is some classes that are especially tricky. Calc 2 is notoriously one of those. Diff EQ, depending on who you have. And then within your engineering fields, I don't know the specifics, but certain classes probably have a reputation. But there is resources available generally for these things. Because at the end of the day, it is financially beneficial for UCF for you to graduate. This is one of those fun things. We're in a capitalist society. Whether you like it or not, that's the reality. And so if it is financially beneficial for someone to do something, it is far more likely to happen. Whether you like it or not, that's just kind of the world that it is right now. Could change, but for now that's how it is. And it is financially beneficial for UCF to get you all graduated and passing and staying in the same major. So therefore they provide services related to that. You know, ideally UCF also cares about you all and all that kind of jazz, and that's good. But you can definitely rely on it's beneficial to them money-wise. So you can take that to the bank. So they offer SARC and all those kind of things to that end. All right. Does anyone have any questions about any logistics or stuff like that? I can almost guarantee if you're having a challenge, someone else is. So it's always good to mention it to me so I can help out. All right, cool. All right, 1D kinematics, y'all. So last week, we went through and we did units and we did vectors and we had a great time. They were arrows with an amount and a direction. And today, so 1D kinematics. What a fancy sounding word. It's motion. It's the physics of motion. So we're going to talk about position, displacement, velocity, acceleration, and it's one-dimensional because we start simple and we go from there. So 1D means you are either you're moving in a straight line. That straight line could be up, down. That straight line could be left, right. That straight line can even be at an angle. We'll do that with our lab on Wednesday. One way or the other, it's a straight line. You can go back and forth in that line. So vectors will not necessarily come into play too much in this. You do have the whole left is negative, right is positive, up is positive, down is negative. For now, we're just introducing the variables and the equations, and this is going to be the most equation. I'm literally going to get to a slide, and it's just going to be, bam, here's a bunch of equations. And we'll talk through those equations, but 1D kinematics is very much a toolbox section, where I kind of get to a section and say, here's all the equations you use for kinematics. And we'll do our best to kind of understand where they came from, but at the end of the day, it's like a bunch of Allen wrenches. You got to use the right Allen wrench for the job when we get to that side. So, yeah, we're going to define some of the measurements associated with that, position, velocity, acceleration. We're going to determine them using other given information, because at the end of the day, if everything was just given to you, I don't know really what you're doing. A lot of your job will be finding new things based on this, predict this. And then we'll talk about graphs. Graphs are incredibly useful. Graphs are pictures for data. That's what graphs are useful for. So a graph shows you a picture of a bunch of data. You can either look at a list of 1,000 data points, or you can look at a single graph. And the graph is way easier to interpret than 1,000 data points. That's why we made the graphs last time and all of that. All right, so I already kind of mentioned this. The word kinematics, fancy vocab word, and it's not going to show up on the test. So don't worry, you never need to have like things. You don't need to ever have the definitions of words down, but they're good to know. Studying object's motion. That's what all that kind of stuff, so that everyone's on the same page. So displacement, velocity, acceleration, we'll provide those definitions, and that'll be set. And they're pretty much the ones that every single person uses. They are going to match for the most, but for now, this is my demonstration equipment. This is Demo Duck. He was a staple in my high school class, and he will be a staple in this class as well. He's a demonstration duck. He's got a hard job, but he loves doing it. His job is basically to be my object in motion. So I will throw him, I will toss him. He loves it, right? He's like the crash test dummy. So my first question to you all, I haven't defined anything to you. My question to you all is, what is Demo Duck's position? Spelled correctly. All right, what is Demo Duck's position? I'm not going to even give multiple choices for this. Decide as a group. Discuss as a group. Come up with a consensus. Discuss with a group. I'm not going to even say come up with a consensus. If you can, good on you all. What is Demo Duck's position? Right now, there's Demo Duck. He is sitting on some whiteboards. What is his position? Feel free to mingle and hear what people are saying. We'll do the discussion. I'm going to do this same thing for velocity and acceleration. You can probably guess why. Yeah, sure. Yeah, it's a great idea. Zero? What do you want to define as a reference? What is a reference? Okay. Nice. What do y'all think over here? What's the deal? Zero? Okay. All right, so I got lots of interesting, so I, moseyed around, got some thoughts. I heard zero. I heard not moving. I heard depends on its reference point. So to that end, there was a couple interesting things here. One thing to remember, don't forget your units. So if you do give a number, you always want to say 0 what? So you can say 0 meters, but then that gets to the next point, which is the reference point. So if y'all remember way back when, people used to think that the Earth was the center of the universe. And to be honest, if you want the Earth to be the center of the universe, it totally can be. To that end, if you had to describe where this duck was to someone who could not see it, that's kind of what position is. Position is a description of where something is located so that someone who does not see the object knows exactly where it is. So to that end, think about the description you came up with. If we said 0 meters, if you just said that to someone, what do you think the immediate question would be that they ask? Yeah. From where? Which is, again, it makes sense when you kind of think about 0 meters from where. Someone that can't see it, that would be kind of the follow-up. And that is the reference point. You have to define a reference point. If someone doesn't know where 0 is located, i.e. if you want to say the center of the universe or whatever that may be, you can't define where something's located, which is a really interesting kind of thought process. We're going to introduce this whole reference point, and eventually you can also call it a reference frame. That's going to be a recurring theme in these PowerPoints. You have to have a reference. Otherwise, if you say something's 5 meters away, the follow-up question is from where? But in addition to that, let's say this thing's 3 meters away. Let's say I just introduced 3 meters away. Or you know what? Let's make it 1 meter away. 1 meter away makes a shape around me. A sphere. 1 meter away from me is any point on a sphere around me. So because of that, remember vectors and all that goodness, position is a vector with, and I only put 2 dimensions here, but the reality is it's 3 dimensions. I just put 2 just to keep things simple. Position has a x component, a y component, and a z component. Position does not have time in it, so that's why there's not 4 dimensions. Time is its own thing. But position is where it's located. It can be written as a vector. This is why we have to have vectors. It's how far away it is, and also in what direction. Remember, that's all vector is. And again, in this case, I just put 2 dimensions because that's all we're going to work with in this class, but the reality is the world is 3 dimensions. If you define where something's located, its position, it has an x component, a y component, and a z component. And there's some rules of thumb for position, like for reference frames. Generally, people will take the ground as 0 for the y component. The x component, we generally take where it starts. In general, we kind of take where it starts as 0 for the x component. But yeah, it's generally, you don't have to think too much about it, but it is something you have to keep in mind. It matters. From what is kind of the question. And the base unit is meters. So every equation that we use moving forward, if you need to plug position into that, you need to convert it to meters. That's going to be a rule. That's moving forward. Every time we do any math, you have to be in the base unit. For a position, that's meters. Anytime I give you all a unit, that's the base unit. So if I give you a problem and it's centimeters, you have to convert it. Millimeters, have to convert it. Kilometers, have to convert it. It's just how these things go. All right, the next one is going to be fairly, not too much of a stretch from this. Position is where you're located. It's where you're at some moment in time. What if you move? That's displacement. Displacement is how far you've, let me actually use the formal wording here because this is really important. The difference between the final position and the initial position. The difference between the final position and the initial position. So we have that variable r. That's going to be our variable for displacement. That's just kind of what people have chosen. It's a vector. That's why it's got... So this notation here with the little arrow, that just denotes it's a vector. That's going to be a really common thing we're going to see. So r here, this is the vector. It's an arrow. Just like when you draw a vector, it's an arrow. The delta here just means subtract. So the formal wording here says the difference, which means you subtract. We use this delta. This is the Greek letter delta. This triangle, it means change. It means you subtract